So the discs and the washers are really the same thing. For the discs, we took our shape and we spun it, and it creates a circle, and then those are discs. The washers is the exact same thing. You're going to take your shape and spin it. The only difference is that there's a hole punched through the middle that you subtract out. That's the only difference. So what we're doing here is the exact same thing we did last time. It's just you're subtracting out that smaller radius. So it's the pi is out front because it's pi r squared. It's the bigger radius squared minus the smaller radius squared is all that that is. But let's just review again. If you have a horizontal axis of revolution, so horizontal like the x-axis, if that's what you're spinning around, the x-axis or anything that's horizontal like the x-axis, that's going to be dx. And if you spin around a vertical axis of rotation, then that's dy. So if it's like the x-axis, it's dx. If it's vertical like the y-axis, it's dy. All right, so find the volume of the solid generated by revolving blah, blah, blah. They're all going to start out like saying that. So the first thing we have to do is graph these. So y equals x squared, that is a basic parent function parabola. We have 0, 0, 1, 1, 2, 4, and then the same points on the other side. Are you all writing with pencil? We figured that out from last time. Okay, because we're going to erase some stuff. Now this one we're going to need to rearrange, okay? Because we don't have x or y by itself. So no matter what, we're going to have to make a decision. Now this says we're spinning around the x-axis. That means it's a dx problem. Everything is right side up and life makes sense. So we would want to get y by itself. What would we do? Square root. Y equals square root of 8x. And then we're going to need to figure out some numbers to plug in. So it's still going to start at 0, 0. What else can we plug in? Yeah, I would skip 1 because 1 times 8, square root of 8. I don't know that without a calculator. But if we plug in 2, 2 times 8, 16, square root of 16, 4. So look, it's going to intersect here and here, but this one would be a sideways parabola. So it's going to do something like this is what it would look like. And I'm not being super picky about the rest of it because I'm about ready to erase that stuff. This little like leaf is the part that you want to focus on. So erase all the stuff like outside of that. I'm gonna need to go grab a new eraser because this one's practically done. So it looks like a little like leaf or flower petal or something. I don't know what it looks like. So we want to take that shape and spin it. And you have to use your imagination here. You have to imagine the shape coming up out of the paper and then I guess like going down into the paper. It's spinning around and around, making circles, and we're spinning around the x-axis. So I call this the ghost shape. Draw yourself a ghost shape over the x-axis. And the reason it's going to be washers instead of discs is you're going to end up with a hole in the middle. So you kind of have to use your imagination. Like if you draw in your circles, like one of these is going to go all the way to the edges. And then the inside one is just going to kind of touch the inside. So like if you look at it this way, because I want you to imagine the three-dimensional object that gets created, it would be a cereal bowl that you could actually put cereal in this time. Do you remember I brought up last time it's a cereal bowl? You can't put any cereal in because it's like solid the whole way through. This one would actually have a hole you could put stuff in. Weirdly, the inside of the bowl would be shaped like this. Do you get what I'm saying? Like, so maybe it's a fancy candy dish. Also, it would be kind of coming to a point on the bottom, so it might sort of like fall over, but it's round is what I want you to imagine, okay? So set up the framework of the problem. It's going to be pi r squared minus r squared dx. Set it up blank because then you won't forget the pi and you won't forget the squareds. And honestly, a lot of times on the free response on the AP exam, they'll make the setup worth a point. So if you even do that and fill this in with garbage, you'll get a point. Like the format of it, they'll make that worth a point. So like just do that. Now it's dx. So for your boundaries, look at your x-axis. It'll be where to where? 0 to 2. And then we have to do the bigger radius minus the smaller one. So the bigger one goes all the way to the edges. And it's upper graph minus lower graph, but the lower graph is the axis. So that's just going to be nothing. Which one was our upper graph? This one here. Which one is that? Yeah, that's this one. And so it would be square root of 8x. That goes right there. And then the inside one, that's this guy right here. And again, it's upper graph minus lower graph, but the lower graph's the axis, so that's 0. So we just want this one, which was x squared. Now this one we can do by hand. If they get really, really bad, we'll type them in the calculator, but this one's not going to be too terrible. We just sort of need to clean it up a bit before we do the antiderivative. What's this first part going to be? Yeah, just 8x, right? Square root and squared are going to cancel. Minus, and then what would this second part give us? Yeah, x to the 4th, good. Then we'll do the antiderivative and then upper boundary minus lower boundary. So what is our antiderivative here? Good, 4x squared minus 1/5 x to the 5th, good, such that 0 to 2. A lot of times the lower boundary is 0, which is nice because we don't have to do that one. If you plug in 0 to all these, it's just going to be 0. So basically just plug in 2. 2 squared, 4 times 4, be 16, minus, and then do you remember 2 to the 5th? 32, and then 5th, so 32 fifths. Going to practice that a bunch more times. All right. Find the volume of the solid generated by revolving. Okay, it's always going to say that. Oh, question. Go ahead.
So what's the difference between the discs?
The discs don't have a hole in the middle, so you don't have this subtraction for the second part. It would just be pi r squared and then dx or dy. So it's literally the exact same thing, but you don't have to subtract anything out. It's like solid the whole way through. No, it's not. I was going to teach it all in one day, but then I decided to space it out. It's really not 2 separate lessons. It's really the same thing. You just don't subtract for the other one. All right, so we're going to revolve semicircular region bounded by, oh, big red flag. What do you think this means? It's going to be dy. It's going to be sideways, okay? And the x-axis, and we're going to spin it around the line x equals -1. Let's get some points for this, and I'm going to actually make a table because this one looks a little bit more complicated. I'm going to plug in for y and get x. And you don't have to make a table, but it does help. Let's start by trying 0. If we plug in 0 for y, what do we get for x? 2, good. So 2, 0 is the first point we can put over here. What else can we plug in for y? 1 would not be a good choice because you'd end up with square root of 3. What else could we plug in for y? 2 would be good, and -2. And they're actually both going to give the same result, because if you plug in 2 or -2, when you square them, it's going to be 4, and then 4 minus 4, 0. So you get 0, 2, and 0, -2. And they did say it was going to be a semicircle. And so that does make sense that it looks like that, except I did not draw it very great, but whatever. So it said that and the y-axis. So this is our shape here. And so we're going to spin that around x equals -1. So here is x equals -1. I usually just dot that in. That's what we're going to spin around. And so you want to draw your ghost shape on the other side. The ghost shape is like the reflection of it. It's just to give you a visual so you can see what's going on. And so your outside circle is going to go all the way to the edges. And the inside circle just kind of touches the hole that you're punching out. So if you want to imagine this, it would be not quite a sphere, because you see how it's sort of like elongated, but like a bead, I guess, with a hole punched right through the middle. Or I guess like a really thick donut. But it's round, okay? Like a globe that you punched a hole through, except also sort of squashed. Like, okay, you're smiling, you're seeing it. Okay, I just want to make sure you know what's going on. All right, so set up the framework, pi and then r squared minus r squared dy. And so when you do your boundaries, they need to be y values since it's a dy problem. So look at your y-axis, it'll be from where to where? -2 to 2. And then your radius is going to be right graph minus left graph. So look, it's going to be from here all the way to your axis of rotation. So right graph minus left graph. So which one is the right graph? Yeah, this square root of blah, blah, blah. That's that one. Minus, what is this left graph that I've dotted in here? Good. So it's minus -1, which would be +1. Okay, so it is this weird square root +1. The other way sometimes people think about that is like just visually, instead of right graph minus left graph, just look. Do you see how this part we have shaded is the function? And then plus one more unit for this right here. Like you can think of it that way too, just visually. And then your inside radius, you kind of catch a break with this one. It's from here to here. Well, what's that distance? 1. Like from there to there, that radius is just 1. We will be typing this one in the calculator because I'm not dealing with that mess. But typing it is also a skill. So give it a try. I will confess to you, I don't love this part because if you hit one button, it's going to be wrong. But just give it a shot. You want to make it look exactly like it does there. Oh, and also, do you remember, even though it says Y, we're going to type what? We're going to type X because we have an X button, so that's convenient. The calculator will never know. It'll be our little secret. I'm going to scroll back so you can see mine if you want to look at it. And you guys know you have this insert and delete key right here, so that if you just want to change one thing, you don't have to wipe out the whole everything. Delete will delete just one thing at a time. And then if you do second delete, that INS is insert, like it'll insert one thing. So like, for example, oh, I wanted this to be a, I want to delete that 1 and make it a 3. Do you see what I'm saying? Or I guess you can type right over top of it, but it'll allow you to delete and insert one thing at a time so you don't have to wipe out the whole everything. Does anyone think they got an answer? Oh, mine's thinking. Did yours have to think for a little bit? Okay. Don't hit any other buttons while it's processing. Yep, me too. And truncate. That's good. Don't do anything, just truncate it. Consider the first quadrant region bounded by y squared equals x. If you wanted to get y by itself, what would you need to do? Square root. So y is going to equal, and it would be a plus and minus square root. It's going to be a sideways parabola. So what are some points we could put on that? Where's the starting point? Like the easy places are 0, 0, 1, 1, and then also 1, -1. It's going to be a sideways parabola. 4, 2, 4, -2. And actually, I guess if you only want to draw the top part, because it said first quadrant region, right? Because I'm going to erase the rest of this anyway. So the first quadrant part, the x-axis, and then the line x equals 4. So this is the shape that we're considering here. And then just kind of erase everything else around that. And then I made this parts A, B, and C so that we could just use the same shape over and over again. So if you want to just go ahead and copy that for parts B and C as well, we're going to use the same shape. And we'll do A and B together here, and then I'm going to have you guys try C on your own. And I guess I was just thinking about this. When you square root this, you technically do get plus and minus, but actually we can just do the plus and leave out the minus, right? Why? We can technically just do the positive one because it said what? Yeah, like only the first quadrant. We're going to end up squaring everything anyhow, so it's not really going to matter because when you square stuff, it's going to turn positive anyway. But actually, I was just thinking of that. Technically, there would be a plus minus there, but they told us only first quadrant, so we don't really need that. All right, so for letter A, we're going to spin around the y-axis. So draw yourself a ghost shape on the other side of the y-axis. Like your reflection, just so you can sort of imagine it here. And your outside circle goes all the way to the edges. This is just so you can sort of imagine it three-dimensionally. Like that's going to go all the way to the edges. And then the inside one just touches the inside edges. So what would that look like? The outside circle would be like flat on the outside. Like, you know what I think of as like an outdoor swimming pool? Do you know how it's like flat the whole way around? And then the inside, so I guess it would be like an outdoor swimming pool, except the inside would be weird. Actually, cool. That'd be cool. I'd swim in a pool like that. So like the outside is flat, and then the inside is curved like down to that center point. That'd be neat. We should make a pool like that. That'd be cool. All right, so dx or dy? What axis are we revolving around? Dy. Okay, so pi r squared minus r squared dy. If you go around the x or the y axis, it's kind of straightforward. Dx is for the x axis, dy is for the y axis. It's when you shift it somewhere else that you kind of need to like think a little harder about it. So boundaries need to be y values. Look at your y axis. Where to where? 0 to 2. Now this is your outside radius. You can think of it as right graph minus left graph if you want, but because that's flat, it's actually just a number. What's our outside radius? 4. Yeah, from there to there is 4 units. So 4. And then your inside radius is from here to here. So it's right graph minus left graph, but the left graph's the axis, so that's just 0. Which one is our right graph? This one right here. Now, it would be just y squared. And that is confusing because like one's one way and one is the other. But if it says dy at the end, make sure you only put y's in there. Like it shouldn't mismatch. Now this one we can do by hand. We just sort of need to clean it up a little bit. What will that give us if we sort of like simplify? Yeah, 16 minus y to the 4th. And then that's an easy antiderivative, so we'll do that one by hand. It'll be 16. Good. I get so many people that put x there, and I totally get why that happens. But if it's dy, make sure you put y. 16y minus. Good. And then such that 0 to 2, and then basically just plug in 2, because 0 is going to give you 0. So pi times 32 minus 32 fifths. All right, this one, I apologize. Our ghost shape is going to kind of go off the page a little bit. We're gonna spin around the line x equals 6. So here is x equals 6. And your ghost shape is gonna like go off the paper. I'm sorry. It's gonna do something like that. So your outside circle is gonna go all the way to the edges. And then your inside circle just touches the insides. So dx or dy? Good. Do you see how this is the y-axis? It's like we just scooted the y-axis over a little bit. So dy. So pi r squared minus r squared dy. So look at your y-axis for your boundaries. It's going to be from where to where? Zero to 2. And your outside radius goes all the way to the edge. So it's going to be right graph minus left graph. What is our right graph? 6. Good. It's just 6 minus, what's our left graph? Yeah, like that equate. It was y squared, wasn't it? All right, so 6 minus y squared. And then this is your inside radius, and you can think of it as right graph minus left graph if you want, but what's that distance? 2. I would just think of that as 2, like from there to there is 2 units. Now we can do this one by hand as well. We're just gonna have to do a little bit of algebra first. That won't hurt you, I promise, all right? 6 minus y squared squared. If you can imagine it in your head, that's cool. If you wanna write it out twice, this is what we're doing, and you just have to distribute it all. I feel like that's a reasonable expectation at this level that you guys can distribute stuff. Okay, like you can be mad at me if you want, but I think you can do it. So 6 times 6. 36. This will give you minus 6y squared. This will give you minus 6y squared. So altogether, minus 12y squared. And then plus y to the 4th. Minus 4. Here's what I would do. If you're all writing with pencil, you can do this. Instead of writing minus 4, I would just change the 36 to a 32. Like just combine the like terms. So that's the algebra. I believe in you. You can do it. Now we're going to do the antiderivative. So pi stays out front. What's our antiderivative? 32y minus 4y cubed, 4y to the 3rd, plus 1/5 y to the 5th. Good. Such that 0 to 2, basically just plug in 2. You gonna make it, Kevin? You doing all right? Hanging in there? All right, so just plug in 2. That'll be 32 times 2. That'll be 64 minus, let's see, 2 cubed, 8 times 4, 32, and then plus 32 fifths. So whatever that is.
Upper graph minus lower graph. What's the upper?
Did you get your ghost shape to look like this?
Yes, the upper is 2. Oh, what's that?
So pi r squared minus r squared. Did you put dx or dy?
Yes.
Yes, good. So what are your boundaries? 0 to 4. They also like oftentimes will make the pi and the integral 0 to 4 worth a point. So if you fill in the rest of this with nonsense, you'll get the point out of that. So like always like try, okay? So outside radius, that's this distance. So that just is 2 units. So like that's just gonna be 2. So here's the smaller one. What's your upper graph? It's gonna be upper minus lower. So what's the upper graph? 2, and then minus the lower graph is square root of x. And you can just put that in your calculator. So if it was dy, then you need to use like the y squared. If it was dx, we rearranged it and you had to use the square root of x.
No, I know that.
Okay.
The last thing. The last column is different.
It just depends on what's going on. So for this one, the part that was flat was the inside part. For this one, the part that was flat was the outside part. So it kind of just depends on what your picture ended up looking like, which is why drawing it is so important so that you have that visual. What'd you get from your calculator?
41.88 seconds.
Nice processing. Me too.
Yeah.